Ladies and gentlemen, please welcome to the stage Zhamak Dehghani, Director of Emerging Technologies, North America, ThoughtWorks.
Hi, everyone. It's wonderful to be here. So this morning, I'm going to talk about data mesh, and most importantly, from the perspective of self-serve platform. How do you need to think about and build your platform or next generation infrastructure to support a data mesh configuration, to support a data mesh architecture? But for some of you who may not have heard about data mesh and know what it's about, so I'm going to start with a quick and brief introduction of what it is, and for you who know about data mesh, maybe you can start putting the hat of an infrastructure engineer or an infrastructure product owner to see how these shifts that we talk about has an impact on the infrastructure itself. So what's data mesh? Data mesh is a decentralized sociotechnical approach in managing and accessing analytical data at scale. So I've got a few words highlighted here that I think that we can double click on very quickly. So what's this sociotechnical approach? People often ask me, is data mesh an operating model? Is data mesh an architecture? Is it a technology? It's really all of the above, because we're talking about the transformation and a paradigm shift in how we both organize our teams, how we structure our architecture, and structure the ownership of the data from traditionally a centralized mode to a decentralized mode. So it's all of the above, hence it's socio-technical. And its focus is really on analytical data, and particularly the scale, a new form of scale. So you might say, well, since the early 2000s, we have been faced with this scale. We've solved the problem of volume of scale as we started kind of collecting data from all corners of the globe and tried to analyze them. And yes, we had the distributed file systems and MapReduce and parallelization of data processing to be able to handle that. And then later on, we had the problem of variety. So we moved from structured data to semi-structured and unstructured, and images and text and voice and all of those things. And we had the creation of object stores and processing tools to deal with variety. And with the birth of mobile, or the adoption of the mobile for every single touch point and every single activity on the internet, we saw the velocity of the data flowing into the organizations. And we had the streaming backbone in place, right? The Kafkas of the world, the Pulsars of the world, and so on. So what is left to deal with? I think what's left to deal with right now is the complexity that the structure of our organizations, the fact that the data is ubiquitous, the data that we need today to satisfy the aspirations we have as in how to use that data doesn't come from a single business unit, doesn't come from a couple of applications. It comes from within the organization, from every application that runs and touches, the customers. Beyond the bounds of organizations, come from an ecosystem of partners that you're getting kind of data from and collaborating. And on the other side, we have the complexity that our usages have gone beyond reporting or niche statistical kind of analysis or niche AI and ML here and there to wanting to embed AI into every single function that organization runs, right? So then with that comes, and the continuous change, the pace of change. We are facing with a new scale, the scale of a new kind. So how does this affect kind of, what do we mean by analytical data? Why we have to focus on this? So just what's the analytical data? Is the data that the primary user of that are data scientists and data analysts. What do they need it? They need it for a spectrum of tasks that they do, whether they are training their machine learning models and looking at kind of how the data shifted and what the facts of business and points of truth that happen so they can extrapolate and insights from it, or we're doing some sort of a trend analysis and doing kind of metrics and dashboards and reports. And the spectrum of use cases, the category of those is quite wide. I just put a few examples here. And the nature of the data is quite different from kind of the transactional data, the microservices data, the data that keeps the state of your application. You have this historical view of your data. So often you're looking at the data as an infinite amount of information happened over the course of time. So you can do those trend analysis, you can do the projections. It has to reflect the facts of your business, right? It has to be, that has business truthfulness. It's ubiquitous and it has a large scale. So that hasn't changed in terms of the volume and the speed. Where does that data live today? What does the architecture look like that would that we applied. And when I say architecture, I mean at the global level, at the organizational level. And that implies the team structures, right? So today we have this operational data plane. It's basically the systems, the teams that run our business operations, as in applications that are running the business, to serving the customers, whether these are microservices or legacy applications, or back office or front office. And they have their own transactional data, right? They have structured or semi-structured transactional information. And on the other side of the organization, often under the control of the BI or data team, we have the data lakes or data warehouse. And the expectation is that we have this labyrinth of pipelines to get data out of our operational systems, transform it, cleanse it, and then push it into some form of a lake or warehouse. And on top of this, we have this governance model that is a synchronization point on top of the organization, try to kind of get their arms around this data. Which data do we trust? Which data is reliable? What does truth mean actually? And the security of that data. So there's a lot to kind of manage here. But the point of failure, a couple of big points of failure as we talk about this scale of new kind, as we talk about this complexity. And one is the failures that we see are around scale. As the number of consumers scale, as the number of sources scale, we're seeing organizations kind of slow down. So, if I simplify it in one kind of one notion, it's that really the structure of our organizations and the structure of our architectures are designed in a way that we end up with this centralized bottleneck, right? We end up with a centralized kind of warehouse or lake or data team that is supposed to get data that, honestly, the sources have no incentive of providing truthful or reliable data from all of these operational systems and provide it to people that they don't even know what they might be using the data for. So it's just this disconnected and centralized model. So really, the genesis of data mesh was these problems that we saw in the wild, and it really started, at least my exposure to these problems around 2018, that we needed a new paradigm. We needed a new model that, with the increase of business complexity, with this expansion of sources and consumption models, the organizations yet can get value from data, yet can be immune to change. So businesses are changing, the data models are changing, and that doesn't have a continuous cascading effects on your pipelines and breakdown of your kind of the whole analytics system, right? Analytics function. So really the objective for data mesh is respond gracefully to change, sustain agility as the organizations grow, and to be honest, have a proportionate and a rational spending to the value that we get. I mean, we spend a lot of money in data and AI, and we're still having trouble to really get value from it. So there are a bunch of shifts that needs to happen, and I put a list here. I won't go through every single one of them, but the ones that I wanted to kind of emphasize on is we talked about this. We kind of need to move away from this centralized organizational thinking and architecture thinking to some form of a distributedness, right? So we have had distributed architectures at the level of physical layers. So we've had distributed file systems, distributed query, federated query systems, like all of we're at this conference for one, the tools that exist like Dremio, but at the architectural level, at the organizational level, we need to kind of bring this distribution to align business. And the way we align business and tech with microservices, we're going to extend that and align analytical data to that model of scaling out organizations. The notion of the pipelines, we kind of need to address that accidental complexity that we happen to create, in my opinion, create clear ownership. And most importantly, think about our data infrastructure with a new lens. And this is what I kind of want to talk to you about, that if we restructure our data in a decentralized way at a logical level, right, at the data ownership and architecture level, at the disco physical level, you may choose to put them all in the same lake object store. But at the logical level, we're giving autonomy to teams to own their data, to have an independent life cycle of managing their analytical data. At the same time, we need to get those teams to provide that data as a product, as in it can be shared easily, it can be consumed easily, and have a computational kind of policy management and a governance model that can still, despite distribution of the data, be able to have that data be compliant or have that data to be interoperable with the other data points, right, in the organization. For all of this to be possible, there is a foundational pillar that Data Mesh calls as the self-serve infrastructure as a platform. And it contains a lot of the tooling that exists, a lot of tooling and protocols and standards that got generated as part of our migration from kind of warehouse to lake, but it adds new layers to it. So very quickly, what does domain ownership look like? So we will start kind of decomposing this centralized ownership to independent data teams and independent domain teams now providing their data as a product independently. And some of these data products could be the ones that are sitting adjacent to your, I don't know, order management system or whatever the point of origin that the operational system is, and it's providing a new way to look at that data in the analytical form. Remember that temporal view of your kind of immutable facts that have happened. And some of these domains might be aggregates, right? So that you can aggregate from multiple data products and create a holistic view of your customer or holistic view of the products that you have. And some of these, domains might be created to align with a certain use cases, right? So maybe there is a predictive analysis that's telling you what is the adoption of your products or the consumption of the products on a quarterly or seasonal basis, and that generates its own new data. So you end up with this model that a particular domain not only now provides the systems, the teams, that operational plane, not only provides the APIs and microservices and all good things that we had to run the business, but now has new accountability to provide this view of analytical data. So I'm giving you a quick example in a digital digital world, that digital streaming world, that let's say you have this podcasting manages the podcast, creating podcast listenership around that, but now provides this analytical view of, okay, what are the podcast listeners demographics or podcast, top podcasts daily. These are the new analytical endpoints that providing that sort of data. So then what do we need this kind of data as a product? And again, from the infrastructure point of view, this is a big departure from how we thought about or imagined data and how we should imagine data as a product and what are those new constructs. So what's data as a product? Simply, according to Marty Kagan, every successful product needs to have these capabilities, be valuable, feasible to create, and usable, right? So let's double click on the usable aspect of the data. So I put a list of attributes here that I think are important to data usability. And out of these ones, they're all important. But again, from infrastructure perspective, so we want the data to be discoverable, right? So our infrastructure should allow ease of search and browsing and discovering your data product. Each data product independently need to be understandable. So infrastructure should support good documentation, good articulation of SLOs, and what are the guarantees this data product provides. Easily addressable, secure. And if you come down that list, the second last one, natively accessible. So what does it mean? This product, this data as a product, who are the users? Who are the customers that we're trying to delight? Well, there are the data scientists and data analysts, right? Today, the way they access the native tools that they use to use the data are actually quite diverse. I know we've been at this battle of, oh no, everybody needs to use SQL, this algebraic language. Oh no, everybody should use some flow-like languages and process the data, or we should do something mixed in between. The reality is all of those options to access the data are valid. Some use cases really require SQL-based kind of querying of the data. Some require just analyzing features and reading through your object files and reading through the columns of the data that you have. And some use cases actually want to see the events. So then if you think about it, the same semantic, the same data product, the podcast listeners, let's say demographic or the top daily podcast might be provided in different modes of access, right? The same data, different data points. But because we've had this domain-oriented organization of the data, we're not going to keep all of the data in one warehouse or keep all the data in one lake. We're going to keep the same domain, but across different storage, perhaps technologies or modes of access technologies. So then that leads to this new idea, the architectural quantum, the smallest unit of your architecture, that this infrastructure now needs to host and run independently and a job so that this unit, this data product quantum, can do its job. What is its job? Serving trustworthy, high quality data to the users. So what does this include, this quantum? What should it have? What are those structural components to do its job? Well, it has to have data, right? That's why we're here. And we said polyglot access to the data. So it has to have those access to the storage, of course, the infrastructure that stores the data, and it contains the domain-oriented data sets, right? And it could be one or multiple data sets, however you design your domain to give autonomy to a particular team. So you have your polyglot data. It has the computational context and the code that runs in that context that maintains that data. So again, the big departure is that we don't have some externalized code pipeline outside of this unit of architecture that its job is to process some data and dump it somewhere else for someone to pick up. Actually, that pipeline, that code, becomes embedded as an integral parts of this quantum, neo quantum, and its job is, well, it could be, transforming the upstream data. Let's say your podcast application is generating events. The job of this data product is turning those events to a long-standing, let's say, temporal view of those events, or aggregate those and give you some sort of a daily snapshot, whatever the users of your data needs, right? For that semantic of listener, but the daily, let's say, listens. So it could be a machine learning model that is running as creating new data sets. And it needs to have also as a specification what it expects from infrastructure. What does it need to run and do its job? Structurally, it has, again, I talk about this structure aspects of data product because it's really the job of the infrastructure to support it, right? To build it. It will have input data ports, a way of getting data from upstream. So maybe the microservice is serving its data as a product, or it could be an upstream data product, and we'll have multiple ways of serving that data back. And if we just put this input output ports in an example, that podcast listens demographic data product is getting data from your podcast service in some form, and it's also getting data from your user profile data product, and put them together and comes up with the kind of the demographics. So then let's look at the infrastructure, right? So the reason I put the data infrastructure as a pillar for data mesh was this question that how do we do this? Like, how physically is possible, or financially from cost and operational perspective, it could be possible that different domains run, maintain their data products. And we know that data platform and data infrastructure tooling has quite a lot of bits and pieces to configure and monitor and provision. So how can they do that without duplicated effort? How can we reduce the cognitive load that we just put on these teams, these operational teams? And that's really the role of the platform, right? So, and we're not new to platform. The technologies exist today, and we have done I think, great job in the operational world to be able to abstract complexity. So the way I want us to think about this new platform is really to think about it as from the perspective of the consumers. How can I really provide a set of capabilities through APIs, through clear interfaces that removes friction from the data product developer's daily job to maintain and manage the lifecycle of data products? How can I ease the task of a data product owner, whose job is to know who's using the data product? Is the quality of the data product is according to the SLOs that she's guaranteed? How can we satisfy the data consumers? And again, data consumers are very diverse. You have a spectrum from the coding scientist to non-coding data scientists to data analysts and drag and drop into dashboards to data analysts that work, with code. So how can we satisfy their experience? And I'll just pick a very, very simple notation: lollipops and a plane. And the reason I do that, because again, I want to bring your focus to not the guts of implementation. Of course, that's engineering, we will do that, but to really what these clear interfaces, these lollipops interfaces need to be, and this mathematical plane that just abstracts complexity behind it and elevates us. So that's just the notation, that's the intention behind this notation. So there are a lot of capabilities we need here, and I try to give some form of a classification, I suppose, and not the only way to classify, but I find this very useful coming from this user-centric, consumer-centric view of infrastructure. The bottom layer of infrastructure, the stuff that we have today, right? We've got networking, we still have to network these data products together. We still need big data storage. We still need federated queries. We still need data transformation. These are the tools we need today. But if you put yourself, again, in the shoes of that, e-commerce team or podcast team that now has a big responsibility in providing us analytical data, how can we reduce the cognitive load of those teams? How can we provide a new set of abstractions and interfaces so that they focus on one thing only, which is the transformation code that they need to run to maintain that data and the integrity of the data that they're providing. Not anything else around it, like remove the cognitive load for debugging the infrastructure or how to configure it and so on. So we come up with the new sets of APIs for declaratively create these data products, to read data products. And finally, because we're not talking about a single data product, we're talking about a mesh of connected data products, then we need to think about a new category of experiences, which is how do I browse search the lineage across the mesh? How do I browse the knowledge graph that was created by connecting these data products and linking the data together? How do I secure? Some people want to centrally author the policies that gets enforced by every data product. So I refrain from using the traditional notions like data planes and control planes for a purpose, because I want us to focus on the experiences that the platforms are providing for their users. So let's go through one of those examples. Let's go through managing the lifecycle of a data product by a data product developer. And this data product developer might be that podcast team that is now thinking about, okay, I've got these users of my analytical data, what sort of analytics I need to provide, or it could be data scientists and say, well, I'm now generating a new set of data and I need to put that into a data product to serve it, right? So they start with perhaps incepting, exploring, sourcing, right? Connecting their data product to the source, figuring out, okay, where the data actually coming from that I need. After that exploration, they need to quickly bootstrap and build a data product. They test it, they deploy it, they monitor it, they maintain it, version it over time, evolve it, and then finally maybe one day retire it. And this is not a linear process, right? They keep iterating over this. So the promise of data mesh is that I'm going to let you, as an independent team, as an independent data product, to do this, manage this life cycle independently and autonomously from all of the other data products. So this won't, updating your data product should not destabilize the whole mesh, right? And you should have confidence to do that. So let's go through some of those examples. When I incept, when I explore, when I source, what sort of capability I need from my data platform? I need to be able to search perhaps the mesh to see what's there. I need to be easily discovered, connect to a data product, need to query, or if I want to get that input data port through a query, be able to constitute those queries and perhaps run them on some sort of an interval base, or I need to be able to subscribe to the data port to see when the new data comes, I make my query and get the data that I need. On the other side, I need to be able to declaratively describe what my data products is, what are my expectations from the infrastructure, what do I need, what's the size of the storage that I might need, or the computation that I might need, and be able to describe that and then build my data, focus on the code, build, deploy it. So then what's the interface to this platform? Well, as a data product owner, the minimal information I need to focus on is the code, how would I get the data, right? Where it's coming from? How do I ingest it or consume it? How do I transform it? What do I serve? And then the specification of what do I expect from my infrastructure, right? What are the structural or traits or policies that I need to be in place? So then I deploy this artifacts to my data product experience plane, which in turn goes and provision all the bells and whistles that I need to run my data product. And that includes, encapsulating today a lot of diverse technologies under this logical unit of the data product, right? You need your kind of transformation engines to run your code. You need your storage types. You need your, query engines. You need a lot of stuff coming together and pretending that this is just one nice unit. And then that layer itself, well, then it delegates a ton of kind of provisioning calls to the lower layers, to the utilities to provision, the streaming topics that you need, or the lake storage files that you need, and all of those things that actually is going to come together in a tenancy model that allows you to run your data product as a separate tenant on the infrastructure, right? Let's come to the data product consumer side of this. The consumer needs to, let's say I'm a data scientist, I start with a hypothesis. Can I explore and get some insight out of my data? Is there a correlation between, I don't know, the products, so podcast listeners, and I don't know, the weather forecast on the day? Do they listen on different things? So depending on the weather. So then I need to be able to explore data. I need to again source it, and then once I have this hypothesis modeled into some form, I need to train that model. Assume this is not an reinforcement learning that it's just going to learn in production. Let's assume that we're getting, in this example, we're consuming data from the sources and we're training our model. We engineer our features, the pieces that actually makes an impact on the model behavior, and then we deploy, observe the model, and evolve it. So I'm going to double click on the data consumption side of it, which on the other hand, you can think of it as a data sharing side of the data products, right? And data mesh, for good reason, puts these sort of constraints around what the nature of the data when it's shared has to be. So we already talked about multimodal access, right? Read-only and immutable to me are non-negotiable, because the last thing you want is change the data underneath somebody who has already consumed it. And the way to do that, the way to manage, retrospective kind of make changes to the data is through this biotemporal sharing of the data, that your data is always shared as in a biotemporal mode. It has a processing time when we process this event and shared it as files, tables, whatever, and when the event actually happens. And it could be a single point in time, or it could be a duration of time, a window over which you're doing your aggregate. So the platform now provides this kind of read functions or query functions that really considers the time as a primary access. And the time could be the latest. It doesn't have to always be a window that spans across multiple data points in time, but it could be from the latest to now, which is like one snapshot. And then the platform should also allow that polyglots, right? I might have the same data represented semantically, or like if we talk about the space and time kind of continuum, temporal, but many spatial topologies, right? Some data sets may be best expressed as events because the skew between the event time and processing time is very low, so we're just putting the events. Some might be best expressed as structured or semi-structured and so on. So then if you put yourself in that example, again, you have these different kinds of users, and they may need, for their particular use case, access the same semantic in different syntax and different ways of querying and different ways of consuming the data. And the job of all of this, to provide all of this in this mode, in the new way of configuring the lake, the new way of configuring the warehouse, the new way of configuring your events is with the platform, to give tenancy to every data product, that their multimodal mode of access is accessible. So the big transformation, if I want to summarize it from the platform perspective, is really around, instead of thinking about platform as one big, integrated proprietary thing that we're building, as a set of protocols, a set of APIs that are interoperable and we can compose different capabilities together, really moving from the idea that a data specialist will be using these capabilities to how can I bring those generalists along, those generalist experts that can go from one field to another field, how can bring those guys along and they be able to build and consume data products, moving away from expressing how to provision this data product to declare what the final state needs to be. And again, I double click, emphasize, when you're getting started today with your platform in your organization, before you say, oh, I need a control plane or I need this mechanical implementation, think about the experience you're providing to your users, and then think about the engineering, of course, that goes beyond it. This requires a new, again, governance model, a governance model that allows you to not only decentralize, but also create, interoperability and some level of standardization, embrace dynamic topology, a lot of concerns. But again, the one to focus on is this: if we can automate these policies and code them in the platform and get the platform to execute them, what does this look like, right? So it would look like a bunch of organizational concerns, like okay, we need to have a federated team of these data product owners to come together and decide what actual policy they want to standardize on, hopefully a minimal set. But when they do that, the platform should be able, we should be able to, in some sort of a Turing complete or incomplete way of coding that policy and get the platform to execute it and implement it in an automated way. And not only that, be able to embed that execution into the data product itself. I mean, we've gone through the zero, trust architecture models that really allows, or new architectural models in the operational world, that policies are embedded in every unit of your architecture. And here I put a quick example of, like, let's say we want to standardize metadata representation, and we can have an agent that emits metadata from the, from the data product, and that agent could be embedded in the platform. So for folks that are visually inclined, and I know I'm running out of time, so you've got your operational plane in data mesh world, you've got your analytical plane, but now they're connected very differently. They're connected over domains. There's no pipeline in between. The pipelines are the codes embedded into the data product. Data products are responsible for quality data. Nobody else should be cleansing your data for you. You are cleaning your data. The platform itself has multiple planes that we talked about, and the policies that should be automated and coded and implemented by the platform. We've done this, so this is not all theory. We've done this. These are some numbers that I put. This has been a 2-year journey at one of our clients. We really went from weeks of developing a data product by really automating the platform to hours, going from 20 data products on day, year 1 to 300 plus, and serving our customers or the data product users from, a handful to hundreds of happy data product users, and build a ton of use cases, analytical use cases on top. If you want to learn more, there's a community. You can kind of join this grassroots community that formed, and they talk too much. I don't catch up with them as much because there's just a lot of conversations. Good conversations are happening. I run a 4-day course in September that we immerse ourselves with your teammates and people around the globe on the topic, and the book is coming out in Q4. The early release is already available. You can join and get it from O'Reilly website for free, for a month of free access. So thank you for that. Hopefully you find this helpful.